Okay, today I'm going to go over some factoring review. So let's start with if we have a difference of squares. So let's say we have two terms and we have squares. Okay, so difference of squares has the basic format a squared minus b squared. So I have two perfect squares with a minus in the middle. And I can factor that as a parenthesis, square root of the first, square root of the second, one positive, one negative. So a squared minus b squared, I can factor as a plus b times a minus b. Okay, so this is when we have perfect squares, two terms and squares. So let's do some examples. What if I need to factor the expression 25y squared minus 36? Well, first I say, oh, ding, 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 25, 36. Those are perfect squares, and I have a minus in the middle. So I can factor that as a parenthesis, square root of 25. Y squared is 5y. Square root of 36 is 6 and 6. And one's positive, one's negative. Well, how can I check my answer? Again, I could FOIL this out first, outer, inner, last. Make sure that it simplifies to the same expression, 25y squared minus 36. Or if it is a multiple choice test and you have a graphing calculator, you can graph the expression 25y squared minus 36, graph 5y plus 6 times 5y minus 6. One graph should graph on top of the other, as these should have matching graphs. So just showing you how you can utilize calculator for checking. So let's try another one. What about if we have 18x squared minus 8? Well, 18, 8. I don't have a perfect square, but I have a GCF. What number can I divide both of these numbers by? Well, I can divide both of these numbers by 2. So let's pull out a 2. 2 times what will get us 18x squared? That will be 9x squared. 2 times what will get us negative 8? That would be negative 4. So now, ding, 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 9 and 4, those are perfect squares, special kind of numbers. So I will be able to factor that as a parenthesis. Square root of 9x squared is 3x. Square root of 4 is 2. One's positive, one's negative, and we're done. So again, one way to check your answer is you could graph 2 times 9x squared minus 4, or 18x squared minus 8, and that should match 2 times 3x plus 2 times 3x minus 2. Last one, what if we have 16x squared plus 125? Well, ding, 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 16 is a perfect square. 125, that's not a perfect square, plus we have a positive in the middle. That is not a difference of squares, so this is not factorable. Or you could say already simplified. I cannot break that apart anymore. So if you have two terms, perfect squares with a minus in the middle, look for a difference of squares. So what if we have two terms but we don't have squares? What if we have cubes? A cubed and b cubed. Or a cubed minus b cubed. Okay, so if I have a sum of cubes, so a cubed plus b cubed, well, I can factor that, break that down by taking a plus b times a squared minus ab, and the last one's always positive, plus b squared. And if I have a difference of cubes, a cubed minus b cubed, then I'm going to have a minus b times a squared plus ab, and the last one's always positive, plus b squared. So a sum or a difference of cubes. The only thing that changes are these signs. So let's practice factoring some of these. So what if I have the expression x cubed minus 8? So I want to break this down into smaller components. So do I have a perfect cube? And actually, let's refresh our memory on what some perfect cubes are, because some of us might have forgotten. So cube root of 1 is 1. Cube root of 8 is 2. Cube root of 27 is 3. Cube root of 64 is 4. Cube root of 125 is 5. So if we look at x cubed minus 8, let's think about, can we rewrite this as a something cubed minus a something cubed? And we can. Cube root of x cubed is x. Cube root of 8 is 2. So in regards to our formula here, our a is our x value, our b is 2. So we can factor this as parenthesis, parenthesis again. Our signs, I like to do signs first. If this is minus, the first sign is minus, the second sign is positive, the last one is always positive. So our a value here is x, so we're going to have x minus 2 times x squared plus multiply 2x plus 2 squared, which is 4. So if we simplify, x minus 2 times x squared plus 2x plus 4. So let's try another one. What if we have 8x cubed plus 27? Can we rewrite this as a something cubed plus a something cubed? Well, cube root of 8 is 2, and cube root of x cubed is x. Cube root of 27 is 3. So my a equivalent is 2x, my b equivalent is 3. So I can factor this. Again, I like to do signs first. Again, if we have a plus, that means the first one's positive, the second one's negative, the third one's always positive. So I'm going to have a 2x plus 3. I'm going to have 2x squared minus, we're going to multiply 3 times 2x. And plus 3 squared. So to simplify, 2x plus 3 times 4x squared minus 3 times 2 is 6x plus 9. And we're done. Okay, what if we have 3 terms? Okay, so what if we have 3 terms in a quadratic where a equals 1? So I have a quadratic, x squared plus a bx plus c. So I have a trinomial quadratic, and I only have a 1x squared, so a here equals 1. I can factor that, break that apart as parenthesis, parenthesis. So x plus or minus something times x plus or minus something. And how do we figure out what that something is? I'm looking to find 2 numbers that multiply to c, but add to b. So these 2 numbers here, they need to multiply to get c, and they need to add to get b. So let's do an example of that. What if I need to factor x squared plus 9x plus 20? So again, yes, I have a is 1, I have a 1x squared, I have a trinomial. I don't have a GCF, anything in common. So I ask myself, can I find two numbers that multiply to 20 but add to 9? Well, I can. Two numbers that multiply to 20 to add to 9 would be 5 and 4, both positive. And the only way to get x squared is x times x. So again, how can I check my answer? I can FOIL this out, first, outer, inner, last. Or I can graph and see if these two graphs match up exactly. So what about this problem? Let's factor 4n squared minus 20n plus 24. Well, I don't have a 1x squared, but do I have a GCF? And I think I do, because I can divide all of these by 4. So let's factor out the 4. I'm left with n squared minus 5n plus 6. And then I'm looking for two numbers that multiply to 6 but add to negative 5. Well, numbers that multiply to 6 but add to negative 5, that's going to be a negative 3 and a negative 2. Again, just carry down the GCF of 4. So 4n squared minus 20n plus 24 can be factored as 4 times n minus 3 times n minus 2. And again, how can you check this? You could FOIL it out, or you could graph. This graph should match exactly with the graph of 4n squared minus 20n plus 24. So let's try one more. What if we have negative x squared minus 3x plus 28? Well, I don't have a 1x squared. I have a negative x squared. So let's factor out that negative. Let's factor out the GCF, because 99% of the time, if we can make our x squared positive, it will be much, much easier for us. So if I factor out a negative, that just means I change all the signs. Negative becomes positive, positive becomes negative. So again, I'm just factoring out GCF. Divide by negative 1. Okay, and then I'm going to ask myself, can I find two numbers that multiply to negative 8 but add to 3? Well, I can. Positive 7 times negative 3. So again, if I FOIL that out, I should get negative x squared minus 3x plus 28, or I can graph. Well, what if a is not a 1x squared? What if I have a number in front of the x squared and I don't have a GCF? So last set of factoring is when I have 3 terms. And again, I still have a quadratic, but this time a is not 1. I don't have a 1x squared. I have a number in front of it. So I have an ax squared plus or minus some bx plus or minus c. Well, how am I going to factor that? Well, it's a little different how I factor that. I'm going to have a set of steps. So while we write out the steps, let's go ahead and solve a problem so that I can walk you through the steps as we do it. So let's say I have the quadratic 7x squared plus 29x plus 4. First, always I should start with GCF. Okay, let's see. 7, 29, 4. Is there a certain number that I can factor out or divide by that is common to all 3? And there is not. So what we're going to do is when I don't have a 1x squared, I'm going to turn it into a 1x squared. So my first step is always GCF if you have it. We did not have it here. So now we're going to turn it into a 1x squared. So to turn it into a 1x squared, we're going to do what's called slide. So I'm going to take this a value, 7, and I'm going to slide it and multiply to 4. So sliding means that we are going to multiply a times c. if I multiply x squared plus 29x, 7 times 4 is 28. Well, next I'm going to factor. Parenthesis, parenthesis. So can I find two numbers that multiply to 28 but add to 29? Well, that's the easy option of 28 and 1. And again, the only way to get x squared is x times x. Well, now I need to undo what I did. I multiplied 7 times 4, so now I need to divide. I need to divide so that I can undo my multiplying. So I'm going to divide by a. And reduce. So my a value here was 7, so I'm going to divide by 7 on each of the right-hand sides. Well, 28 divided by 7 divides evenly. That is 4. Well, x plus 1/7 does not divide evenly, so what I need to do is what's called bottoms up. So bottoms up is when I take this denominator that does not cancel and I make it the coefficient in front of the x. So I am left with x plus 4 times 7x plus 1. So remember, slide, divide, bottoms up. Again, how can I check my answer? I can graph. If you have a graphing calculator, make sure that your original equation matches right on top of your factored. Or I could FOIL out if I do not have access to a calculator. So again, yellow part is divide. And here we have bottoms up. So let's try one more. So let's try one more. So what if we have the quadratic 2x squared minus 3x minus 9? So again, first step is always GCF, 2, 3, 9. Well, 2 and 3, those are prime, so we're not going to be able to factor anything, so no GCF. So next we slide. I take my 2 and I multiply it by the 9. So negative 9 times 2 is a negative 18. Next, I'm going to factor, parenthesis, parenthesis. I'm looking for two numbers that multiply to negative 18 but add to negative 3. Well, this would be a negative 6 and a positive 3. Well, now I need to undo my sliding. So I need to divide. Well, I multiplied by 2, so now I need to divide by 2. X minus 3 times, again, x plus 3 halves does not simplify. So lastly, I need to bottoms up. So x minus 3 times 2x plus 3. So again, you can check your answer by FOILing out or graphing. X minus 3 times 2x plus 3 should graph right on top of 2x squared minus 3x minus 9. And that is factoring a quadratic when a does not equal 1.